This video will help you learn how to convert standard form numbers to scientific notation. There will be detailed notes and also practice problems along the way, so I encourage you to write down the notes beyond just the numbers, but also the vocabulary that's being used and also some words out to the side so you can really understand the steps along the way. So let's first take a look at what a standard number looks like. So a number in standard form can be a really big number, 6,025,000, or a really small number. You know, any numbers after the decimal is tenths, hundredths, thousands, so it's really a small number. And your homework may say converted to scientific notation. So this number in the end, once you do all the steps, is going to look something like this. Okay, so that's the difference in a standard form. It has commas. It's usually a big number or it's a decimal. And then for scientific notation, you have positive integers on one side times 10 to the power of something. It could be a positive or a negative. So let's understand scientific notation. The first thing you would need to do is write down all the positive integers on the left side. Okay. With those positive integers, it's going to include a decimal. And you place the decimal with a number between 1 and 9 to the left side of the decimal. Okay, so it's going to be positive integers, a decimal, times 10 to the power of a positive or a negative number. Okay, so that power is going to be positive or negative. A positive power means the number is really big. And a negative power, really small number. So again, you're going to have the positive integers you wrote out here, a decimal, the number to the left of it between 1 and 9, times 10 to a power. It could be a positive or a negative power. Okay, so let's look at some examples and talk about it as we go. So we'll start with standard form. The number is going to be 8,354,000. And we need to convert this to scientific notation. And I'll start using the abbreviation of SF for standard form and SEN for scientific notation. Okay, the first thing we need to do is write out all of the positive integers. So that'll be these numbers here, 8, 3, 5, and 4. You only write out the positive integers. You do not need a 0 or anything. Okay, then we have to decide where to place the decimal. The decimal is going to have a number to the left of it between 1 and 9, which is this 8. So your decimal will be right here. So the number to the left of the decimal is between 1 and 9. Then it's going to be times 10 to a power. So how do we find the power? You think about, where did you initially put this decimal? And we put it between the 8 and the 3. So I'm going to go here, and wherever these jumps are, moving it to the right, how many decimal spots out it would be for us to find our power. And it's going to be a positive power. So we went 1, 2, 3, 4, 5, 6. Okay, so it's going to be a positive 6. So you start from the decimal and you just count out the jumps to the right from where you initially put the decimal all the way out to the end of the zeros. Okay, what you don't want to do is write 354 times 10 to the third, meaning this is just about the zeros at the end. That's not what you're supposed to do. And if the video is moving too fast, because I'll start to pick it up some, just pause the video. Our next number in standard form. You realize some of these numbers get really big, but don't be intimidated by the numbers. Just stay doing the steps to it. So first we're going to write out all of our positive integers. A 2, a 0, a 3, and an 8. The number to the left of the decimal has to be between 1 and 9. That's this number, so I'm going to put my decimal here. Times 10 to a power is going to be a positive power because the number is really big and we're going to be counting to the right. So whenever we're moving to the right, it's going to be a positive integer. Okay, so again, starting where I put the decimal, we're just going to count the jumps. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you convert this from standard form to scientific notation. Your teacher may go into detail how it's multiplied and all of that. This is just some additional notes so you can get to the point and get your homework done from what you initially learned. Okay, another number, scientific notation. Starting at standard form, going to scientific notation. We're going to write down our positive integers. So we're going to put 7.0 here, times 10. We're going to be counting out to the right. So we're counting the jumps. 1, 2, 3, 4, 5, 6. And that's it. Okay, we're going to look at a standard number that's really small. So 0, 0, 0, 0, 6, 1, 2. We still have to do the same basic steps to put it in scientific notation. So first I need to write down my positive integers. 6, 1, 2. Still going to put the decimal here because the number to the left is between 1 and 9. And now I'm moving to the left, counting from one decimal to the other. So this is going to be a negative power. So if that decimal that I placed here, and I'm counting out left, 1, 2, 3, 4, 5. It's going to be a negative 5. Okay, that is this number written in scientific notation. Okay, let's do another small number where we start in standard form. 0, 0, 0, B6. We go to scientific notation. I'll write out my positive integers, 3, 5, 6. Place my number between the numbers where the number on the left will be between 1 and 9. This is a very small number, so I'm going to be moving to the left and have a negative power. Okay, so my new decimals here, I'm moving out 1, 2, 3, 4, times 10 to the negative 4. Let's look at a few more practice problems. Okay, really big numbers, so we know we're going to be moving to the right. And that's going to give us a positive power. Our decimal has to be between the positive integers, where the number on the left side is between 1 and 9. So writing out my positive integers of 13, putting my decimal between 1 and 3, times 10 to a positive power. So I'm going to start where I put the decimal, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and just count the jumps all the way out. We went from standard form to scientific notation. Okay. Standard form, this is the number 0065, or 65 thousandths, very small number. We're going to write out our positive integers of a 6 and a 5. Place the decimal between 6 and 5, so the number on the left side is between 1 and 9. Now I'm just going to count the jumps to the left. Because it's a very small number, it's going to be a negative power. So we have 1, 2, 3 jumps. So times 10 to the third power. And it's going to be negative. And 2 more. I'm pretty sure if you follow the steps and the rules, that this should become very easy for you. Standard form. Okay. We're going to go to scientific notation. Write out our positive integers. Place our decimal. Times 10 to a negative power, because the number is really small. 4, 5, 6, 7, 8 jumps, negative 8. Our last example, standard form. Okay, we're going to write out all the positive integers, and when you have a 0 included with those positive integers, you go ahead on and write that out too. So scientific notation would be 9, 3, 0, 2, 4, times 10 to a power. Place your decimal. Count your jumps to the right. 3, 4, 5, 6. And that's it. Simple steps from converting standard form to scientific notation. If you have any additional questions, just email me by visiting Youth to Reality. And also, if you share or tag this on Instagram, at youth to reality _ academics, you'll earn free study hall credits.